Welcome to today's session on leveraging Cloud MLOps to detect, investigate security threats with confidence. I'm Girishwar. I'm a VP at Sumo Logic, and I have my colleague David along with me. David, would you like to introduce yourself, sir?
Sure. I work on the machine learning applications at Sumo Logic. I have a longstanding interest in machine learning and its various applications, and working with the engineering and product development team here.
Fantastic. Thanks, David. If you can advance to the next slide. So, folks, what we want to do today is to provide you a different perspective on how advanced analytics and machine learning can be used to solve common as well as advanced security threat detection challenges that are commonplace in today's environment. But before we get started, we want to provide you a quick overview on Sumo Logic and in particular David's team and the ML machine learning program at Sumo Logic. We'll discuss some of the common security challenges that many practitioners and analysts experience today, and we'll provide a perspective of what we think has not worked very well to date, and also provide you a perspective of both as a developer and as well as a practitioner, or how to use cloud scale and machine learning ops or ML ops to advance your security posture. Next slide, David. So a little bit about Sumo. It will be remiss on our part if we jump into talking about ML without introducing Sumo. Sumo is an innovative company. We have been around for about 11 years now. We were so-called born in the cloud. So everything what we do from a security perspective is native to cloud. We are 100% in cloud. We are cloud native. What we really offer is a cloud native platform that can be used to solve a wide range of security solutions such as SIEM, SOAR, and security analytics, posture management, workload protection, plus observability solution for app observability, as well as multi-cloud observability and a lot more. We have more than 2,300 customers on record, and we have roughly about 900 employees. We are quite proud of the fact that we have hundreds of thousands of daily active users on our platform, using it to solve a wide range of security and observability use cases. And a little bit data on us from a data context is that we have our customers use Sumo solutions to solve a wide range of use cases which are inherently data driven. And exabyte and quadrillion records, I had to actually do the calculation here. It comes to 10 to the power 15 and greater. That's the amount of data that's analyzed or used within the Sumo cloud native platform today. Next slide, David.
Yeah, so I can talk a little bit about the machine learning and global data aspects of Sumo Logic. So from what we mean by global data is something that we refer to as the Global Intelligence Service, which is a kind of like automated crowdsourcing via the cloud. And what this allows our customers to do is see how their operational and security data compare to others, most specifically the other population of other Sumo Logic customers. And some examples you might be familiar with from your own life of this kind of thing is, for example, here in California, our utility company provides us with some kind of benchmarking of how much electricity a given home in a comparable home might be using, and you can see are you using more or less than they would have expected. Likewise, most likely your healthcare provider, if you're getting various standard blood work done, will provide those results to you along with something like a reference range. So what are the typical or expected concentrations per milliliter in the blood of some particular measurement? And this is really important because as a non-expert, those quantities might otherwise not be very meaningful to you. So that additional context about how your data compares to everybody else's data helps you better understand your own situation. And we sort of translate that same intuition into the Sumo Logic platform. We can get into that in a little bit more detail further in this talk, but this ultimately gets packaged and exposed out to our customers in the form of these solutions and apps. For example, if you're running the Nginx web server, how does your latency or error rates compare to other customers running the same infrastructure? Under the hood, this is all powered by the underlying sort of core Sumo Logic log management platform. And some of these statistics that Girish was mentioning earlier, this machinery for computing these sort of global benchmarks and models is scanning over 30 petabytes per day to deliver that information to our individual customers. Besides that, there's also some of this, what you could call like more silo machine learning capabilities, log clustering, anomaly or outlier detection, and forecasting that you as an individual customer of the platform can apply kind of in isolation to your own data. And then where things can really get interesting is when we can take that global perspective and then combine that with machine learning. So we can train machine learning model on the global population data and then use that to do some interesting product features as far as securities and observability are concerned. So that's what we'll be focusing on later in the talk.
Cool. That sounds awesome, David. So cloud native to the fullest extent possible. No downloading of software. No need to go find machines that have enough memory or CPU, right? So you're overcoming all those problems by this ML architecture and MLOps approach you have, right?
Yeah, absolutely. So Sumo Logic is a SaaS service, so there's very limited, there's some instrumentation and data collection, but all the heavy lifting is kind of happening in the cloud.
Nice. Okay, thanks, David. So I'll spend a little bit of time introducing a problem statement so that then you can drive the rest of the session, David. So, folks, what I wanted to do is to kind of recap some of the common challenges that security security practitioners experience on a daily basis. We always hear about blind spots. I don't really know who's lurking behind the scenes or where are they hiding, how did they attack, how did they get in, and then what we are hearing from our customers, and this is even though the adoption of powerful machines and automations and orchestration continues to grow, still bulk of the security teams are inherently adopting or continuing to use manual workflows. We are seeing there is a little bit of a ray of sunshine, so to speak, with the adoption of tools like SOAR, that is security orchestration, automation, and response, but still predominantly manual. So there needs to be better ways not only to overcome these workflows, but what commonly is referred to as alert fatigue. It's fairly common for companies to, or even universities or enterprises to have tens of thousands of alerts or noisy alerts. How do you decipher that and make sense out of that? That's where I think the role of automation and analytics and machine learning shows significant potential. Next slide. Perfect. Yeah, just like David highlighted here, the lens that we want to take folks here is to say alert fatigue or too many alerts or noisy alerts is a common problem, has been a common problem in the industry for many, many years now. What we wanted to share is to actually recap some of the challenges the industry has gone through and then provide an alternate way in which how we are architected our solution, as well as how our customers are using it to have what I call a low-touch ML approach to solve common security challenges. David?
Yeah, so we're really going to be focusing and kind of getting back to this problem of the alert fatigue, and specifically we're going to be talking about machine learning based approaches. But as we go through, I'll kind of try to call out a few sort of tips or advice that we've kind of picked up along the way on this journey of trying to deliver this cloud-based security solution for our customers. So tip number one is to really think and consider whether or why to do machine learning at all. Does it really make sense in your particular situation, right? If you know exactly what you're trying to do, it might be the case that you can simply do that, simply look for that. Now, the reason in the security domain why that's always not necessarily going to be possible is there is kind of course, like an adversarial cat and mouse dynamic, right? The attackers are continuously evolving more sophisticated approaches, and it's very much a moving target in that sense. And for machine learning practitioners, this is another sort of field where a lot of people are working, is quantitative finance or kind of investment. And a particular speaker at one of the machine learning meetups in San Francisco once sort of characterized it as if you were trying to train a visual chair detector, but once you learn how to detect a chair, chairs start changing shape to evade you. And in his particular case, he was talking about searching for trading opportunities in the stock market, but that also applies just as well to the security domain. The attackers literally are trying to evade you. And to that end, the premise of machine learning for security is to automatically learn. But the tricky part is learn what, right? Something. And most commonly, when people talk about machine learning and security applications, they very often mean sort of learn normal behaviors and alert on the unusual activity, although there are a lot of other potential applications as well. But really, just saying I'm going to do security and kind of sprinkle some machine learning on it is kind of a dicey proposition. And really, the first thing is to really kind of understand your problem and what you're trying to really achieve, and whether machine learning is going to be a useful tool for doing that. In many cases, it will be, but in some cases, it won't. And you can see this is actually, some search results in the corner. This is a very popular and interesting topic for a lot of people. So I think, Garish, do you want to talk a little bit about some of the challenges with machine learning security today?
Sure. I like the way in which you set this up for David, because there is always this, hey, believe me, I know what I'm doing, the black box approach to things, right? So I love the phrasing here called vendor magic, because I think about 7 or 8 years ago, there was security analytics and ML for security, frankly, got overhyped in my opinion, David. I don't know, would love to hear your viewpoints. It's the whole idea here is, hey, we'll bring in your data to our software, and we'll tell you and report out on the threats and attacks, both external attacks as well as insider threats, right? That's how it was meant to be. But I think here, David, you have a question here, right? What do you mean by risk of overpromise and underdeliver? I know you have something in your mind when you put it there. What are your thoughts here?
Well, right. I mean, as kind of stated before, that there's some challenge where potentially you are going to hope that you can just kind of throw a bunch of kind of garbage in and get magic out, right? And the machine learning can certainly be a very effective technological solution in some contexts, but unless you kind of know exactly what you're trying to evaluate and you know how the machinery kind of works, it can be difficult to really understand what's going on inside the box and trust that it's going to be doing the right thing. And there's just a lot of difficulty to it.
Right. Yeah. No, fair point. Yeah. What comes to mind is the technology that evolved 7 or 8 years ago called UBA, or User Entity Behavior Analytics. If you can advance to the next slide, David. So this is what I want to share with this audience, the evolution of UBA, that's User Entity Behavior Analytics. You can render the entire slide, David. So the whole idea was that this was meant to be a standalone category that is going to replace many existing security tools and technologies. But frankly, a lot of it was overhyped. It was positioned as the next big thing, and ML, everything. There's so much of ML washing going on in the 2014, 2015, that itself did service, because I think the technology showed great promise, but the initial set of tools or products that were so built, they just didn't work. And then it evolved to be, hey, instead of a standalone product that was going to replace multiple tools, it was more of an augmentation strategy, saying, hey, use it with your existing tools. But even in that approach, there was a lot of, I think, what David referred to as overpromise and underdeliver, or zero delivery, right? it just failed to deliver, and it led to, frankly, a little bit of what I call ML disillusionment, right? People losing confidence, and then where things settled from my, at least my lenses, David, if you can read the next one, it's as a capability, machine learning in security is here to stay. We have gotten the very good positive results across in many different domains and industries, but it's more of the reality check, right? The hype cycle, if you use the Gartner analogy, an example, it went through the hype cycle and etc. for disillusionment, right? And now it's kind of more plateau in terms of reality. Machine learning is a great approach to solve certain use cases for enrichment, detection, and investigation, but it's not a standalone category on its own, but rather it works in conjoint format with other existing security tools. So for me, this raises the question, David, does it mean, okay, the black box approach didn't work, so do we go to the complete do it on your own approach?
Yeah, so this is this is a tough call here. So one kind of opposite extreme that you could take it to on the far other end of the spectrum is to just say I don't trust the vendor magic black box and I'm going to do my own thing. And you might get an idea from a cool paper or a blog post or something you saw online in one place or another, or you may even be very creative individual and kind of have your own innovative ideas about how this could be done. And actually doing it in practice is going to be a significant investment of money, time, and you'll grab some off the shelf kind of open source machine learning frameworks and go for it. And what's going to come out the other end there's some uncertainty there. And if you don't have a significant experience on this kind of like from scratch machine learning, that one possible risk here is that it might be harder than you thought, right? Even if you think, after kind of taking these sort of warnings into account. A really interesting paper about fielding production machine learning systems from one of the leading machine learning conferences way back in 2015 kind of shows you what a machine learning end-to-end production system sort of looks like. And the actual sort of quote unquote machine learning part is that tiny black square in the middle. And the rest of it is all of this infrastructure, machine learning engineering, tooling, process, and other sort of challenges around it. So when somebody says, I saw an open source thing online and the core model is on GitHub, that core model, it might just be what's in that black box in the middle, and all of these other boxes, all of this other stuff fielded by one of the, some of the wealthiest and most well-resourced teams and companies in the world is the other part of the equation. And so if you aren't experienced or kind of have those capabilities or willing to make those investments, you might have a bad time. Now, there's some attempts to make it a little bit simpler and kind of wrap up and integrate into some of the machine learning systems to have what can be known as sort of toolkits, where they are providing some sort of modeling capabilities directly in a security data analytics solution. This can still be a big challenge if you again don't have kind of the in-house expertise with the machine learning approaches and technologies. So one sort of example toolkit might offer you the ability to do anomaly detection by fitting statistical distributions to your data and then identifying data points which are not well explained or judged to be low probability by those statistical distributions. But even if they provide all of that capability and tooling, the catch is that you still have to kind of know a little bit about statistical distributions and which one is the right one to model your data with, and how do you interpret the outcomes and the results and the estimated parameters. How do you set perhaps hyperparameters? And this is, all personally, I find this stuff super interesting and engaging. But if you are just trying to get the job done, this might be a bit of a detour into some material that you sort of didn't anticipate investing significant effort into familiarizing yourself with. So that this, even with some tooling support in the form of kind of toolkits and things like this, it can still be a big challenge. So to that end, our sort of like tip number 2 is that, you know, SecOps teams that are by and large, they have a very difficult job. They're certainly experts in their domain, but do they need or want to become experts in adjacent domains like data science or machine learning engineering? You know, they're pretty busy folks and kind of have quite a bit on their plate already. From a data science perspective, you know, there's the modeling, the statistics, the feature engineering. These are the kind of things that we just talked about. Here we have, you know, this is the beta distribution from the previous slide. Is this the right way to model your data? What are those gammas? You might be interested to know that it's a, you know, generalization of the integer factorial to complex numbers with positive real components, and, you know, all of this kind of fun stuff. Again, this is really maybe not how your SecOps team wants to be spending their time. Machine learning engineering, this is basically all of those big blocks from the 2015 research paper, unless there's kind of an entire universe of data pipelines. How do you do model training? How do you do serving? How do you store models? How do you do monitoring of the models? Again, this is kind of emerging as its own challenging kind of market itself of solutions trying to help make machine learning engineers' lives easier. So this is potentially taking on quite a bit more complexity and challenge for your SecOps team. Besides learning all of this, you know, they might have to also become Kubernetes experts to field one of these systems, which is, again, potentially not on their you know, agenda of what they want to spend their time on.
Yeah, so I think your point there, in addition to all the other ones, is if you think you're being breached or if you're experiencing alert fatigue, it's not a 2-hour project to get this going.
That's right. Yeah, we don't want to, you know, your time and team's time is valuable, and we want to really focus on where they're bringing the value. Absolutely. All right. So Sumo's approach, how are we going to, what's our sort of position on how to go after this? One major strain of that is what we previously discussed as the global intelligence, right? And so that's kind of a tip. Number 3, right, is can we do crowdsourcing? And one really nice example of this is the Global Intelligence app for AWS GuardDuty. So if you're not familiar with AWS GuardDuty, it is a service that enables you to monitor and detect unusual, suspicious, or potentially threatening activities or behaviors related to your resources and infrastructure and accounts in AWS itself. So if you are some kind of cloud native enterprise, and all of your app and use data and sort of critical infrastructure is in AWS, you have very good reason to be wanting this kind of monitoring and alerting and things like that on those AWS resources. So these are all just kind of a handful of different examples that they will sort of detect and bring to your attention about your AWS resources. However, as always, the major kind of challenge in security is there's going to potentially be a lot more of these potentially risky or dangerous or suspicious signals than you or your team really have the time, attention, or resources to deeply investigate. So how can we, what does crowdsourcing mean in this context, and how can that kind of help your team contextualize and understand what's going on with that data? So this is the Global Intelligence for AWS GuardDuty app in Sumo Logic. And this is just kind of, there's even more to it, but just for the interest of kind of time, there's 2 things that we'll show you. One is rare threats. So these are threats that we've taken a look horizontally across, you know, all of the members of the Sumo Logic population who have this global intelligence or have this AWS GuardDuty data. And if there are threats that are very rare across that population, we'll kind of highlight those for you individually. Say, okay, AWS GuardDuty has detected these, and these we do not see very often. So those might be especially interesting to you as the security practitioner. On the other side, we have your company's mixture of threats that we see in your environment compared to the global mix. So you might be interested to see that you have far more of these, backdoor style threats than most other companies in the Sumo Logic environment, right? And again, both of these are kind of just like the utility bill benchmarking or the blood work reference ranges. We're going to kind of hopefully help you better contextualize your own data and information by comparing it to that global population. So how does it work under the hood is that we are kind of running these analyses and this infrastructure in the background to compute which are the rare threats and what is the global mix of these threats. And this machinery kind of happens. This is the automated kind of cloud-based crowdsourcing that is going on under the hood. And again, so this is what's kind of scanning all those petabytes to deliver those overlays on top of your own data. And so this across global intelligence for guard duty is just one example, but across a variety of these different applications in the security and observability SRE kind of DevOps space, we've found some great opportunities to kind of enhance the meaning or value of your individual data by kind of overlaying this sort of global perspective. So this is something in security domain that people in general also find very valuable, is this crowdsourcing kind of idea. So that's another tip, is if you can somehow get crowdsourced data, that's very nice.
So
Go
David,
ahead.
if I may, one quick question there. So from a user's perspective, they don't have to do anything other than enabling the service, guard duty and others, right?
That's right. So again, kind of as cloud-based service, you configure the ability to ingest those guard duty threats into Sumo Logic, and then install the app, which is something you can do from the Sumo Logic UI, and right away it'll kind of start generating these insights and overlaying your guard duty threats with these global benchmarks and analyses. That's right.
Thank you.
Okay, so the Cloud SIM and the security insights. So this is a kind of whole, we could talk, go into great depth on this, but we'll just for kind of simplicity, this is the Sumo Cloud SIM offering, and one of the key features of it is this ability to generate security signals. And these can be sort of expert or custom tuned rules and alerts and correlations of different data sources will generate these individual signals that kind of correspond to, again, individually suspicious or potentially risky behaviors that were observed in your environments. And these signals can be annotated with all sorts of additional metadata, and they're available for lots of different kind of products and tools and vendors and things like that. So it can say, okay, users attempted to log in and then they did log in successfully after many failed attempts. Or we see unusual access from IPs that are not typically used in this context, or things of that nature. These can potentially be very valuable, but they'll also potentially, again, the classic problem in security is you might be generating a huge number of these. So one of the major kind of innovations in the Sumo Logic Cloud SIM is this insights idea. And what this is going to do is actually correlate and combine individual signals to create the something called the insight, which is what you might want to alert on. So this is going to say, not only did I see something suspicious happening around the activity originating from this host, I saw several different things that were suspicious around the same host, and that really kind of increases potentially the relevance and confidence that this might actually be something that we really need to take a look at. And you can kind of pull together and correlate these multiple signals and multiple pieces of information to get a more credible and kind of meaningful understanding of what might constitute a threat. Now, we're going to get to, this is kind of the core of we've set up the pieces. We want to apply those global intelligence techniques, this crowdsourcing, to the security insights generated by the Cloud SIM. So again, just to really hammer the point home, the real problem in many cases is just going to be the analyst bottleneck, skilled human attention. There's going to be more signals, more insights, more threats than you really are going to be able to fully investigate. So how can we prioritize or triage? So this other kind of tip, supervised classification. If you can turn your problem, if you're trying to apply machine learning to a given problem domain, casting your problem as supervised classification has a lot of advantages. So what is supervised classification? Basically, in a very kind of simplified sense, given some data points with labels, can you predict future labels? This is kind of what you would learn in a online class on machine learning or kind of one-on-one machine learning. Spam detection, right? These are the spam, these are the not spam. A really kind of classic version is handwritten digit recognition on 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which, if I give you an image, which digit is it? This is probably one of the most well understood and widely applied versions of machine learning. There's a long history, there's kind of well-developed theory, there's a rich ecosystem of software, tooling, process, best practices. This is really kind of a very nice, if you have a problem that can be expressed in this framework, you have a reasonable expectation that you might be able to do something useful with it. So this all sounds great, but what's the potential challenge here is it's hidden in that fact that I said labeled data. You need the labeled data to train the supervised classification model. And in fact, there's entire sort of very exciting research programs in academia and industry about how to overcome this limitation or attack this problem. And in fact, this is a very active sort of startup market as well, entire startups that have kind of sprung up to try to help with the labeled data problem over the years. So that's kind of the price of admission. That's the cost of getting to do frame your problem in this way. So how are we going to combine this Cloud SIM insight and kind of frame it as a combine it with machine learning, right? So we're going to frame it as a supervised classification problem. Given one of these security insights, how likely is it going to be a true positive, right? So of course, in security, the kind of terminology here is there's kind of true positive, false positive, right? The machine, if it sounds the alert and it's really a genuine thing that you need to look into, that's a true positive. If it sounds the alert, but it was just kind of noise or a coincidence or the rule is too sensitive, that's a false positive. And, you've kind of, in some sense, wasted your time. So looking at these insights, how likely are they to be a true positive? And that is how we're going to frame the supervised classification task, right? You have, is it spam or not spam? Is it true positive or false positive? And we're going to train that classifier on these insights. How are we going to get the labeled data? And this is the really nice aspect of how the Cloud SIM is designed, is that the in-product investigation analyst workflow will capture and record the analyst judgments when they close out the case or kind of close out the investigation, as whether they judged it to be the true positive or false positive. So we're not kind of forced to have this whole extra additional effort of people sitting there and kind of curating a huge pile of previous incidents. We're just going to capture it right in line as part of the workflow. What did they close out this insight as? So that's one way to get the labeled data. But another challenge is that you need the more, in some sense, something that you'll often hear from machine learning practitioners is the more labeled data, the better. And so how can we get enough labeled data? And this is where the global aspect comes into play. So we're going to pool these labeled analyst judgments across the global customer population to get even more labeled data. So that's where the power of this kind of crowdsourcing attacks the problem and challenge of getting labeled data for the supervised classification problem of insight relevance.
So David, quickly, so what I think I heard you say indirectly was you're bringing the human in the loop, one, plus getting additional samples and references point through the global community. That's
That
that,
that's
that's pretty cool.
exactly, yeah. So, and again, I guess similar to the guard duty one, aside from having your own analysts working through these insights and closing the cases and providing their annotations, there's you kind of getting we're going to do the machine learning aspect here without individual users or customers kind of getting directly involved in tuning parameters or kind of identifying models themselves, or kind of that full DIY sort of aspect. But at the same time, you do have that kind of transparency into like, why was this insight created, because you can see the sort of constituent signals that fired off in order to sort of create the insight in the first place. So we're not kind of in that totally black box magic vendor area either. So
Nice.
we're kind of trying to navigate between those two extremes. So yeah, exactly. This is a way that basically your SOC can sort of leverage the power of the crowd via this kind of cloud mediated crowdsourcing. And company A might be identifying, they have these particular insights. And the idea is company B, their analysts might have already investigated insights that are very similar, that quite resemble the insights that company A has. And if some of them were false positives, now we can kind of use the machine learning model to transfer that knowledge in some sense to company A and say, your insights over here strongly resemble insights that were identified as false positive elsewhere. And this can potentially save you some time and effort or help you kind of triage and prioritize. But at the same time, it doesn't sort of force your hand. You don't have to kind of directly follow everything that these scores sort of say, but you can use it as one more tool in the box. So how do we do it, right? And this kind of gets into some a little bit more of the details of framing it as a machine learning problem. So once you are trying to apply one of these supervised classification model, we're using sort of a classic fixed length feature vector encoding. Again, to sort of by analogy to that spam, not spam, all of the different counts of different tokens or words in the email, that might be one way to encode an email as a vector, which is what these machine learning algorithms work over. So that's basically how do you kind of translate an insight or an email in the spam case into something that you can feed into one of these supervised classification models. And the representation of an insight in this case is based on the supporting signals. So which rules, what kinds of behaviors, what specific vendor tooling or other kind of MITRE tactics or things like that were associated with each of the individual signals that fed into that insight. And those become the features by which we sort of decide which insights are sort of similar to which other insights, or how the algorithm rather kind of makes those determinations. And it's got, I guess if you're sort of interested in these kind of technical details, it's kind of a moderate dimensionality. It's certainly much more than human could manually work with, but it's this isn't ultra high dimensional fMRI, voxel data or something like that, if you know what that is. So this is a fairly nice and well-behaved way to represent these insights as something the machine learning algorithm can work with. So the actual algorithm itself, from a modeling perspective, the real key sort of trick or innovation here is this ensemble of the global and local models. And sort of a kind of simplified representation of that is above. And what I mean by that is that there's a local model trained only on the judgments of the analysts from your company, your organization, that's local to you. And there's a global model that's trained from that kind of pooled common wisdom and judgments from the broader population. And this can potentially like overcome some problems. So there's potentially this idea of like a cold start. So if the customer, you don't have that many judgments yourself, or only you have analyst judgments from within your own company on certain kinds of threats, we can kind of take advantage of that global aspect to sort of bootstrap up and be able to generate meaningful predictions on insights that are a little bit more further away or different than the insights you've already seen. And the other problem is potentially, what if your analysts, you have a particular way of working where your analysts actually in some sense disagree with the global population, and you don't want those global scores sort of overriding the expertise and judgment of your own team in generating those scores. So this can be addressed by basically tuning that per customer trade-off hyperparameter. So essentially what this means is that the prediction model for these confidence scores attached to the insights is in some sense personalized to you as an individual customer in two different ways. One is via that local function, which is just only derived from your own judgments. And two is via personalized tuning of alpha C in the equation above, that kind of trade-off factor that determines how much to weigh the global model versus the local model. So this is kind of a nice way to frame the problem that sort of navigates a lot of those challenges and trade-offs in a nice and sort of data-driven way. Other than that, again, if you're kind of into the details, the machine learning, aside from that sort of one tweak, by and large, the rest of the modeling machinery sort of follows typical supervised classification best practices. So it's nothing too exotic going on there. Okay, and now this is another kind of really important aspect, tip number 5, for kind of operating this machine learning model in this context is CI and monitoring. Once you're kind of deploying these machine learning models, you're basically in almost kind of like a DevOps SRE capacity of machine learning model. And so we want to follow all of sort of the best practices from modern software delivery. We have unit testing and pre-merge checks on any code changes to the code that kind of governs the model pipeline or the model training or the model serving itself. We are continuously retraining these models to incorporate new threats, new signals, new insights, new judgments, but we only deploy the new model if the estimated performance is above some threshold. So we don't want to accidentally push a new scoring model that's going to cause like a accuracy regression in some sense, or like failures. And we're also testing the probability calibration, which this is a little bit more in the weeds technically, but we want those scores to really actually be meaningful and kind of tell you something useful about, those, is it really, can you interpret a 90 score as kind of like 90% likely? And so this is the final output. You have these kind of global confidence scores attached to the individual insights, and you can use those to kind of understand your individual threats, your insights. You can sort them, you can filter them. It's basically one more piece of information in the mix accessible to your SOC analysts. And so you're kind of gaining all this power of the machine learning to kind of add that global context, that global confidence score, but without sort of having to dig too much into the weeds of the machine learning machinery yourself. And at the same time, it's not overriding or automatically doing anything for you. It's just kind of saying, here's an additional piece of context that you might find useful. So, if you're trying to apply machine learning techniques to your own security applications, I would strongly encourage you to kind of know the pitfalls of both the black box and the full DIY kind of challenges. Really, the crucial thing here is to think very hard about like how to frame your security problem as a machine learning problem. If it's a nice fit, everything will be a lot easier. If it's kind of doesn't make any sense, you're going to, no amount of magic algorithm is going to be able to save you. And most likely label data is going to be critical. And so you really have to think about where are those labels, judgments coming from? How can we get as many as high quality labels as possible to make it work? So that's kind of our experiences trying to attack these challenging security problems with machine learning. All right. Thank you very much for your time and attention.
Thanks, David. Really appreciate you spending time with the audience. Folks, we want to hear from all the ML enthusiasts and people who want to learn or get into this space. I encourage you to reach out to David directly. We have a good ML program at Sumo. And again, from a partnership perspective, reach out to us. And thank you again for attending our session today. Appreciate it.